All right, good evening, Titans. This is Mr. Simpson. This is lesson 3.6, titled Transformations of Graphs of Linear Functions. The first core concept that we're going to cover today are translations. A translation is a transformation that shifts a graph horizontally or vertically, but does not change the size, shape, or orientation of the graph. So first of all, horizontal translations. Again, horizontal will shift the graph either left or right. If this black line is our original function, then the red line would be shifted to the left, and the blue line would be shifted to the right. And again, we'll kind of explain how this happens on the next slide. And then vertical translations, it would move up or down. Now the main thing with the horizontal translation is you have to notice is that if the original function is y equals f of x, and the translated function would be y equals f of x minus h, the x minus h is inside the parentheses, and that is what shifts the graph horizontally. If you look at a vertical translation, again, the original function is y equals f of x. Then the vertical translated function, notice this time what's being added is or subtracted is on the outside of the function, and that will shift the graph up or down. So if we take a look at this first example, our original function, our f of x, is equal to 2x minus 1. Well, now what we're going to do is our g of x is the same function, the f of x, but we're going to increase it by 3. So what that does is if I have my graph, my original function was 2x minus 1, so it has an intercept of a negative 1, a slope of 2, so I go up 2 over 1, and I make my graph. Now, because this function is f of x plus 3, then this makes it have a vertical translation of 3 units up. So I just move every point 3 units up. So I take my y-intercept and I shift that 3 units up. So now instead of being at a negative 1, it's going to be up at 2. And again, horizontal and vertical translations do not change the shape of the graph at all. It just shifts it up or down. So then it would have the same slope, so it would actually be parallel to my original function. If we take a look at the next one, again, our original function is f of x equals 2x minus 1, but now my translated function, t of x they call it, is going to be f of x plus 3. Now because what's being done is on the inside of the parentheses, now this is going to create a horizontal shift. And this is actually going to shift it 3 to the left. You may think, well, how is that 3 to the left when it's x plus 3? Well, the way I think about it is what value would I have to plug in for x to make what's inside the parentheses go to 0? And that's a negative 3, which is why I say it's 3 to the left. Now, if you think about it, the original thing said f of x minus h is the form, and so to make f of x plus 3 in that form, we'd have to write it as f of x minus a negative 3, and so that's also why it's 3 to the left. So again, if I graph it, and I have a negative 1 here, and I go up 2 over 1, and I graph it, well now, just this point that happened here has to happen 3 to the left. So every point is shifted 3 units to the left. So again, horizontal and vertical translations do not change the shape of the graph at all. It just shifts the graph, whatever the graph is, it just shifts it left or right or up and down. The next core concept that we'll discuss tonight is a reflection. A reflection is a transformation that flips a graph over a line called the line of reflection. So there are two lines of reflections that we'll work with. We'll reflect over the x-axis and we'll reflect over the y-axis. The most common type of reflection is the reflection over the x-axis. And so what we end up doing, if you notice this, if the original graph is f of x, then the reflection is the opposite of f of x, which means we're actually multiplying every output by a -1. So every output will end up changing its sign. And for the y-axis, if you notice on here that the negative is inside the parentheses, and so we're actually taking and multiplying the input by a -1 in order to get our points. So let's take a look at an example. So again, our original function is f of x equals 1/2 times x plus 1. And we want to do, they tell us that g of x, our translated function, is going to be the opposite of f of x. Well, it's easiest in this case if we just make a table of values here. And this is going to be our x, and we're going to have our f of x, and then we're going to have the opposite of f of x. Okay? So again, I'm going to plug in -4, -2, and 0 in this case. So if we plug in a -4 into this function right here, half of a -4 is a -2, and -2 plus 1 is a -1, and now if I take the opposite of that, that becomes a +1. Now I'm going to plug in -2. Half of a -2 is a -1, and -1 plus 1 is 0. The opposite of that is still 0. And then I plug 0 in. Half of 0 is 0, plus 1 is 1, and then the opposite of that would be a -1. Well, now let's graph that. Well, the first one, my original function right here, I'm going to graph just using slope-intercept form. So I go up to 1, and I go up 1, and I go over 2, and I have my graph. Okay? And if you notice, these points, the f, the -4, -1, are all right there. So now if I graph my other points, so the points I'm using, these are my x values, and these are my y values. So I have -4, +1, I have -2, 0, and I have 0, -1. And as you notice, this line here that we graphed, this line is a reflection of that one over that x-axis. All right? So now we'll take a look at the other one. All right. Again, here we still have our f of x is equal to 1/2 times x plus 1. And now we're going to do f of a -x. So again, I'm going to make a table of values. And what we plug in, okay, so this time we're going to plug in -2, 0, and 2. So those are what we're plugging in. And then I'm going to take the opposite of that. So this case, that'd be 2, 0, and -2. And then we're going to find out what f of a -x is, meaning I'm plugging in the 2 here. So I do that, and I plug that in, and then half of 2 is 2, 2 plus 1, or half of 2 is 1, 1 plus 1 is 2. Plug 0 in, I get 1, and I plug the -2 in, and half of a -2 is a -1 plus 1 is 0. So again, if I graph this original one using slope-intercept, up 1 and over 2, my graph looks like that. But now I'm going to graph the other point. And so the point I'm graphing, again, this is my x value I'm plugging in, and then this is what my y value would be. So I have -2, 2, okay? And then I'd have 0, 1, and then I have 2, 0. And there's my graph. And again, this time, this graph is reflecting over the y-axis. So when we take the negative times the value that I'm plugging in and then evaluate the function, then it reflects it over the y-axis. If I do it to the output, then it reflects it over the x-axis. And those are just the two types of transformations or translations that we're going to discuss tonight. And we'll have the other ones due over the weekend. So again, have a great evening, and go Titans, and be prepared to do as much as you can tomorrow in class with this.